Okay, so first question is, I sent out over the weekend a study guide for the final. All right, how many of you have received it? Okay, good. Have you printed it out or do you have access to it? All right, okay, so here's the reason why, is that what I've done is I've embedded, in this case, if you'll notice, I've embedded two sites where you can go if you need practice or just to see whether or not you can handle that particular skill. Here's a practice for roots and a practice for irrationals. All right, so that you can just get some practice on it. If you're doing okay with it, then you can also go and in the index in the back of your Algebra II book, you can look up that skill and find out what section it was on, and you can go and look at that presentation of the problems that are in that section. All right, but the idea is that you're going to have roughly an hour and a half, hour and 45 minutes in class to do this final test. It's 20% of your grade, and so it can affect your grade by at most, let's say 3 or 4 points at most. Okay, so if you're in a solid B, right, and you just absolutely have a bad day and bomb it, you may drop 3 or 4 points in your overall average. Right, but it's not going to drop 15 points, right? Because 20% grade. In fact, let me show you how they do that. Let's say that you have an 85. Somebody get out a calculator, okay? Let's say that you have an 85% average, right? And it is 80% of your grade, and then you have 20% for the final. Okay, so what you do is you take your average and multiply it by 0.80. Okay, how much is that?
68.
68. That means if you get a 0 on your final, you end up with a 68. Okay, so this is the minimum grade you have going in. Okay, now let's say that just for the sake of argument, let's say you take a 40. Which is not a very good grade on a final, but what is 20% of 40?
8.
8 points. Add these two together, you get a 76. So you passed. Okay? Now, that's a really bad grade.
Yeah.
But if you'll notice, it only dropped a total of 10 points. Right, so if you're in the 60 range, all right, let's do that. Okay, if this were a 60, which is not a decent grade, but you know it's not passing, so 60 times that is 12 points. All right, add these two together, that's an 80. So you still have a B. So if you had an 85 going into a 20% final, if you get a 60 or higher, you keep your B.
Cool.
Right now, that should take a lot of pressure off.
Yeah.
Right, because everybody's average is in this range, within a few points of this range. So some is higher. Right now, to push your average up is just as difficult as to drop it down so far that you change a letter grade.
Right.
But if it's on the border, it would be to be able to get, like if you have an 85 and want to move it to a 90, now I don't know that we can do that. So let's look at this. We have to have 20%. 20% of X has to equal, this has to be able to get to a 69.5, or from a 68 to an 89.5. All right, that is the half. I need 21 points. Okay, take this number, divide it by 0.20. 106? 107. Okay, so therefore, it is physically or it's mathematically impossible if you have an 85 on a 20% test to be able to push it all the way up to an A. Right, but all you have to do is get a 60 to keep your B. Right, So a person with an 85 average, do they have a lot of pressure? They shouldn't have that much pressure because you have to do extremely less than what you've done all year. Right? And so that's for the study guide. Yes, ma'am?
How much is extra credit worth?
I don't even know. Extra credit is probably going to be worth about 2 points, I think.
Okay.
You know, which 2 points on your average is a lot.
Yeah,
That's
for
good.
sure.
Yeah. All right. Okay. Now, one of the reasons I don't know that is that we just threw out a whole lot of quizzes when we revamped the last month.
Yeah.
And so, because those grades are not in there, the extra credit is going to make a big difference in this quarter, how it changes. So I'm not sure that exactly how we're going to do that. All right. Okay. So now we're going to get back to this. All right. First of all, what is the difference between a rational and the irrational number? Okay. What's the first 4 letters of the first word?
Ratio.
Ratio. What is a ratio? You should know this. Starts with an F.
Fraction.
A fraction. Ratio is a fraction. Okay? So, if the number can be created, if the decimal can be created by a fraction, then it's a rational number. Right now, repeating decimals are rational. Repeating decimals are rational. Whole numbers and integers are rational. Okay? So that's one of the things that happens when you start to try and identify these. There's a lot of people in their minds think that if it's a repeating decimal, it's irrational. That's not true, because, and the best example is, what is 1/3 as a decimal? It's 0.333 repeating. Now, 1/3 is really 3/9. Right? And if you in your calculator take a number and divide it by 9, you will get a repeating decimal every time. In fact, 4/9 is 0.444 repeating. Right? 7/9 is 0.777 repeating. Right? So it's a fraction, but it turns out to be a repeating decimal. All right? That's a way to be able to try to correct this if you don't know it already. Okay? Now, usually this is represented by some number A over some number B.
Right.
All right, now, what's an irrational number? It's a number that cannot be represented. All right? Pi and some roots of x, provided that it's not a perfect square or a perfect cube.
Yeah.
Okay? So the majority of irrational numbers are non-perfect roots. Okay? All right, so that's those two. Now, in non-perfect roots, if I gave you the square root of 12, how do you simplify that? Okay? Is there a perfect square in there? What are the numbers to multiply together to give you 12?
3 times 2 times 2.
All right, okay, but if I look at this is also 4 times 3,
Yeah.
and 4 is a perfect square.
Right.
So the square root of 4 is 2, and so this will be simplified to 2 square root of 3. Now, is that rational or irrational? Come on, what did I say?
Irrational.
It's irrational because that's a root. That's a square root, right?
Yeah.
The 4 went to, so if I gave you the square root of 81, is the square root of 81 rational or irrational? Oh my. Can you simplify that?
Rational.
To what? 9. Is 9 rational or irrational?
It's
Rational. So this, even though it's given you in a square root form, it simplifies to 9, and so it's rational. 9 over 1, or 27 over 3, however you want to be able to make your fraction. Right? But this one, square root of 12, when you simplify it, will not simplify all the way. And so the square root of 3 makes this an irrational. Okay? Does that help?
Yes.
Right, now, if you know those, you're going to be okay as far as this test is concerned, but I didn't see a whole lot of understanding on those responses. Now, some of that has to do with the fact you didn't have me for Algebra 1. Because the section of Algebra 1 that deals with square roots, you're supposed to be able to do that and keep that information. And a lot of times what happens is you do it and then forget it. Because some people don't recognize what is in Algebra 2, and so they don't keep the information after they do the test. Okay, linear equation basics. Okay, what's slope?
Rise over run.
Rise over run. It's the change in the y values divided by the change in the x values. All right, and the intercepts. All right, the intercepts, the x-intercept has an x number and a 0 for the y, so it's on the x-axis. All right, and the y-intercept has a 0 for the x and a number for the y. All right, and both of these values, when plugged into the equation, make it true. All right, so how would you, if you were given slope and an intercept, right, you would plot the intercept and then go rise over run, whether it's positive or negative, and you could be able to identify the graph. Okay, for linear, you're going to have what kind of line? Straight line. Everybody say straight line?
Straight line.
Straight line. Why? What's the first 4 words? First 4 letters? Line. So linear is the adjective form of line. Okay, you didn't know that, did you? Okay, you do now. What is it? Linear is the what? The adjective form of line. So a linear equation, that's the adjective of the noun equation. Just like hard is an adjective of equation. So a hard linear equation has 2 adjectives. One for how difficult it is, and the other one for whether it's straight or not. Okay? Got it?
Got it.
Okay. All right. Now, so that's linear equations. All right, quadratic equation basics. All right, direction, axis, and vertex. Okay, this is part of Algebra 2. It really started with Algebra 1. And I think I've got... No, I don't have that. Okay, all right. Okay, so let's talk about this. All right, how do you know the direction? Or I'm sorry. First of all, what's a quadratic equation look like?
You have an x squared.
X.
No.
Ax squared
No.
plus.
The equation looks like a. Who am I pointing at? I'm pointing at you. Am I pointing at you?
Now you are.
All right. Am I pointing at you? All right. What does a quadratic equation look like? It looks like a U.
Oh.
Duh.
Yeah.
All right. And what is this point called? That's the vertex. That's the vertex. Now, so when it talks about direction, it's talking about is it opening up, down, right, or left?
Right.
Because we're not just in Algebra 1 anymore. If it was pointing this way, okay, do you notice I can have an x that's here or here?
Mm-hmm.
So that's going to be
That's
x squared y, or is it going to be x y squared? Has to be one or the other. This one is the one we're used to, which says y equals, so this is where the x squared is, and this one is x equals.
gotcha.
Okay? Now, so if this is opening to the positive, that means I have a positive value here.
Right.
This is opening to the positive, so that means I have a positive value here. So how would I get a negative? How would I get this? This is y equals negative 4x squared would be one example, but the opening comes from the negative because it's opening down.
Right.
Okay? Now, the axis of symmetry. You should know this one. I'm going to write it. The axis of symmetry in your notes is negative b over 2a. That is the axis of symmetry. All right, now, where does that come from?
Quadratic formula?
Quadratic formula when the discriminant is 0. So that will tell you the axis of symmetry. It goes through the x value of the vertex. And so if you take the x value of the vertex and put it back in the equation, you can find the y value of the vertex. Okay? That's the basics that you're going to have to do for quadratic equations. Okay? It's been a long time ago, but hopefully that is not too difficult. All right, now, okay, this is the one that we are going to do some practice on. All right, conic sections. All right, for conic sections, you first of all, there are 4 kinds. There's circle, ellipse, hyperbola, and parabola. We just talked about the parabola. The parabola is the quadratic equation. Okay, so it's going to open up or down. And the quadratic equation has one square variable and one non-squared variable. Y equals x squared plus 4. Right? The y is to the first power, the x would be to the second power. Okay, so for the parabola, all right, we have one that's squared, one that's not. Okay, what do you see here? These variables, they're both squared.
Right.
Okay, so it's not a parabola. Why? Because a parabola only has one squared variable. All right, now, if they're both squared, if they are added and the coefficients are the same, it's a circle. Okay? So this is a circle, and this is the formula for a circle. Now, the center of the circle is at -3, 5. Remember, it's the opposite of the numbers that you're looking at. All right, and the radius, this would have been a 4, and the radius is 2. So you have a square here, you have a square here, and you have a square of the radius. You know, that should not be news. All right, and then you can plot that. All right, so what do you see here? Where's the center of this circle? 4, -3. What's the radius? No. No, what's the radius? 4. Take the square root of that number. Okay, now, so the harder one would be, would be this problem. All right, now, look at the variables. Both variables are squared. They are added, and the coefficients are the same. In this case, they're both 1. So this is a circle, but what's the center of the circle? There you have to do completing the square.
Right.
All right, what's the major word that I teach for completing the square? Half. Half what? Half the x term. So what's half of this? 5. That makes this x plus 5 squared. However, when I do that, I add a third term, which will be 5 squared, 25. So on this side of the equation, I'm also going to put a 25. Okay? Now, what is half of this term? 6. And so that becomes y plus 6 squared. All right? The third term will be 6 times 6, 36. So I've introduced a 36 here, so I have to put a 36 over here. All right? And then I need to move the 25 to the other side. And now, I have a center located where?
-5.
-5, -6. All right, and the radius will be whatever these are. It looks like, this looks like 50 And if this is 52, this will have a 9 left over. Right? If I take 52, here's 50,
Yep.
and I take 2 away from here, and I leave 3 plus 6, 9.
Yep.
Right? So that makes the radius what? If this turns out to be a 9, what's the radius?
3.
3. Okay? So you put the point at over here. We want the point at -5, -6. 1, 2, 3, 4, 5. Right, which is right there. And then the radius is 3. And then the best I can, I'm going to draw a circle there. That would be the graph of that. Okay? All right, now I'm not going to go back over completing the square. If you don't know it, you need to practice that. Okay? All right, now let's look at the other conic sections real quickly. Okay, all right, what do you see here in this problem? All right, first of all, is it a parabola?
No.
How do you know it's not a parabola?
Because both of the terms are squared.
Say it again. Because both of the variables are squared, so it's not a parabola. So that one's out. All right, now, both y's are squared because it's plus here. Because it's plus here, it's not a hyperbola, because the hyperbola has a minus on one of them. All right, but are the coefficients the same?
No.
No, so instead of having a circle where we're going to go the same distance in both directions, here I'm going to go along the x, I'm going to go 3, well it won't be, I'm sorry. I'm going to go a different direction here than here, but I have to change the form. Right? And when I create this, it's a little bit harder, and I can't remember whether you're supposed to do that or not. Okay, if I take a factor of 9 out of here, what's left? 9 times what is 72?
8.
8. Half of 8
4.
is 4. So that makes that squared. Okay? What's the extra term if this is a 4? 4 times 4 is 16. 16 times 9 has been added, and so I want 16 times 9, which I think is 144.
Yep.
Yeah. 16 times 9. Okay, now, the other one, I'm going to bring a 4 out. Okay, if I take a factor of 4 out of this, what's left? 4 times what is 24? Come on, people. 6, right? And so half of 6 is 3. So now I have this. All right, my extra term is 3 times 3, 9 times 4, which is 36. Okay, these two cancel out, and now I have this. All right, but for the ellipse, this is going to have to be a 1. So I'm going to divide by 36. And when I do dividing by 36, this becomes a 4. And when I divide this one by 36, this becomes a 9. And now I have a factor of 1/4 and a factor of 1/9. So it's not a circle because those coefficients are different. Now, what do I do with this? The x from the center located where? Where's the center?
Oh.
-4, +3. I'm going to go along the x, I'm going to go how far? 2, square root, 2 in each direction. All right, along the y, I'm going to go how far? 3 in each direction. So let's pretend this is where the center was. I'm going to go 2 in each direction, and then I'm going to go 3 in each direction. All right, and what I'm supposed to do is draw a box. All right, and it doesn't matter whether this is a negative or a positive. If it's a positive, I'm going to go inside. If this was a negative for a hyperbola, I'm going to create the diagonals, and then because the x is first along the x-axis, that would go like this. Remember that now?
Yes.
Okay, so I will tell you this, there's no construction on the final that I remember right now. I'll check that. There's no construction on the final, but you may have to identify what it is.
Gotcha. So you mean there's no construction of like drawing the graph?
That means I don't believe you have to do this. I'll have to double check. I don't believe you have to draw it,
But identify.
but you have to identify it. All right, now, I'll double check on that and tell you next week. But that's my recollection. All right, now questions from you about conic sections. No questions?
Well, I have one.
Yes.
Just to determine where you draw the lines on the outside, it's if the x is first, you go along the x.
Right.
The y is
If you
first,
have a hyperbola, this first variable will be the variable on which axis you're going to draw your two lines.
It's x first.
So, because the x is first, this would be like the one that I just drew.
Okay.
Okay? And let's see if we have another one. Here's one here. Okay?
And that one would be.
This one would be going up and down.
Got it. Thank you.
Okay. All right, any other questions? Okay. All right, now, so we can go back to, all right, and here are 3 practice things for identifying that you can pull up on the internet, and I tried to get sites that had the answers on that site so that there wouldn't be a question about, and again, this is all on the handout that I sent you. Okay. And I'm trying not to use them now in case you need them later. Okay, creating inverse functions. All right, you have one inverse function test question. You have one inverse function test question. All right, and the way that you do an inverse function has 2 steps in it. The first step is to change the x and the y. So, still wet here. If I gave you y equals 2x squared minus 15. Okay? And now the inverse function, right, this would be called f of x. The inverse function is written like this. And that's the notation for inverse function. It takes 2 steps. First, you exchange the x and the y, and then you use algebra to get y equals again. So what I would do is I would take this and make the x here equals 2y squared minus 15. Okay, now, the first thing I can do is move the 15. How do I do that? Add, right? So that becomes x plus 15 equals 2y squared. All right, now how do I move the 2? What kind of math is there between the 2 and the y? Can I say it again? Divide. And now, when I divide this by 2, the 2 is gone. All right, how do I get y if I have y squared? Take the square root. And so, y equals the square root of x squared plus 15 divided by 2. I don't have any choice. So this becomes the inverse of f. So this and this are opposites. And what happens on an inverse function, let's say that you take a 3. If you put a 3 in here, that's going to be 9 times 2. 18 minus 15 is, oh, that doesn't work. Let me use a different number. Let's use 4. All right, that's 16 times 2. That's 32. 32 subtract 15 is 17. If you put the 17 in here, you're going to end up with 4 again. Right? 17 plus 15 is how much? 17 plus 15 is 32. 32 divided by 2 is 16. The square root of 16 is 4. So in the inverses, the number that you put in will be the number that you get out when you take both of them. Now we didn't do very much of the proving that the inverse was right. We just did the algebra to get the inverse. Okay, and I think there's one problem on that. Does that make sense?
Yes.
All right. That problem that we just did, that I just made up, the problem on the test is no harder than that.
How many problems are there in class?
I can't remember.
Okay.
It's less than 25, I think.
Whoa.
Wait a minute, I take it back. I don't
think
know.
that's
right.
I don't know. No, each problem, each skill problem is going to be expensive.
Right.
If you get the skill wrong, it's going to cost you.
Gotcha.
Right? But one of the things that we're doing is I don't want you to have a surprise about what you're going to be tested on, so that if you don't get it right, it's because you didn't learn the skill while we were in class. Does that make sense?
Right.
Right, that's a fair test. Right? If you have not seen the presentation of a problem before, you might know how to do it, but you didn't understand that problem was asking you to do whatever that skill was.
Right.
Right? That's a bad test. Because what it didn't do, it didn't get the information out of the student that shows that he or she could do the work. Right? But if we all understand what the question is going to be asking us, then the ones that get it wrong either make a silly math error, or they really didn't have it down to begin with. That's a fair test. It's a fair test question. And so that's the reason I'm doing it this way, is because I want that grade to reflect that you've learned even more than what your test was when we took that chapter. Okay?
Yep.
All right. Now, so inverse functions shouldn't be a problem. Okay. I'm going to hold off on logarithms to next week.
Okay.
All right, so let's look at 7. Solving quadratic equations. Okay, now, most of this is going to be, if you have to solve it, you can always use the quadratic formula. Always use the quadratic formula. It'll take a little bit longer, right? But it will do that. Now, what happens with the discriminant? If the discriminant totals 0, then you have one root. It's a dual root. And if you were graphing it, it would touch the x-axis. So it's sort of like it touches it coming down and touches it again going up, right? If the discriminant is positive, then you have two roots. And so it hits going down, and then it hits coming back up in a different place, right? And if the discriminant is negative, you have no real roots, two imaginary roots, because if this is the x-axis, it comes down and goes back up without touching the x-axis, so we have no value where y is 0. Now again, that shouldn't be news. Okay, now another way to be able to do this is to factor. Okay, and that's what this first line is set up to do. Now, when you factor a harder quadratic equation, you want factors of 2 times -3, which is how much? -6. I want factors of -6 that add up to 5. So my factors of -6 are 2 and 3, 1 and 6. To be able to get a positive 5, I have to have this one. Right? However, they are not the numbers in here. They are the numbers here. So I need -6x, positive 6x and -1x. Now, how do you get a -1x? it has to be a 1 here and an x here and that negative. That's the only way I can get negative 1x, right? So I'm already using a guess and check method to be able to figure this out. Now, how am I going to get 6 if this has to be 2x squared? All right, how do I get 2x squared if I start with x? This has to be what? 2x. So 2x times x is that 2x squared. All right, now, if my total is 6, 2 times what is 6? 3. All right, you found it. Now, while I was driving here today, I thought of something which may help this idea. Okay, I'm waiting for everybody to get that written down. Now, the first year that I taught Algebra 1, I taught Algebra 1 like the book. And I found out that as long as the x squared was 1x squared, everybody was great. But as soon as that x squared was something other than that, I lost about 3/4 of the people. Their skill level dropped down. So what I want to do is I want to show you why that's true. Let's see if I think I got a blank here. I will have a blank in a sec. Where's the... What happened? There it is. Okay, now, let's pretend that I give you something to FOIL. Okay, what's the first thing you do? What's the first thing you do?
3x times 2x.
You multiply 3x times 2x.
Yep.
Right? Okay, and you get
6x squared.
6x squared. Okay, so where did that 6 come from?
3 and the 2.
It came from a 3 and a 2. It could come from a 1 and a 6, but it came from a 3 and a 2. Okay? Now, what's the last thing over on the side over here?
Negative 4 times 5.
Which is negative 20. Where did it come from?
4.
It came from 4 and 5. Right? So, now, the center is this plus this. So the center is negative 8 plus 15, which is plus 7x. Okay? Now, this one I can't get to, but I know one thing. That if I break this down, these numbers have to go in the front of those binomials. And these numbers have to go where? In the back of the binomials. You don't get that? Okay, let me ask you this. All right? Let me get another color here just for this. I think colors, they don't erase as well. But, okay, so let's look at this. This is a 5, and this is a 4. In this problem, they're both here. Okay? Now, this 6 came from what? The 3 and the 2. So, if I look at this number, the values of that total to multiply to be 6 have to come from these two places. Now, it could be 3 times 2, or it could be 6 times 1, but I know one thing: if I multiply these two together, I have to get 6. The same thing is true here. If I multiply these two together, I have to get 20. Right? And so what happens is I factor this, and I factor this, and I know that these two have to split into either 6 and 1 or 2 and 3 in these binomials in the first part. And then these have to go here and here in some fashion. Now, it could be 1, it could be 2, it could be, that's a 5, I'm sorry. It could be 1, it could be 2, it could be 4, it could be 5, it could be 10, or it could be all 20. Right? But all of these factors on this last term have to go in the end of the two binomials. And then all of the front, the leading factor, this coefficient, those factors have to go in the front of the binomial. Otherwise, there was no way to multiply these two things and get this. Does that make a little more sense?
Yes.
All right, let's try one. All right, now, what do you know about the leading coefficients? What do I know about the leading coefficients? What do they have to be?
1 and 5.
Has to be 1 and 5. So this should be 5x, and this should be x. So what I'm looking for, if I can find it, is a prime number, because there's only one pair of factors for a prime number. Okay, now, what choices do I have on this backside? I can have 1 and 4 or 2 and 2. All right, so let's say that I do 2 and 2. All right, now, this is plus, and the signs are the same, right? And this says that it was negative. Right, so therefore, these have to be minus so that they're both the same. Now, what's this inside? Negative 2? What's the outside? 5 times 2. Negative 10. So that would make this a 12. All right? And so if that was the 12, then I've got it. Suppose it wasn't right, because that wasn't a 12. Then I would have to try 4 and 1. Okay? So this is how much now inside? Negative 1x, and this is positive 20. What is positive 20x minus 1? 19. But suppose that wasn't right. Then I would switch these. And now I have negative 4 and positive 5, which would be positive 1x. Okay? But the whole key, what I'm trying to show you, the whole key is that you break this down and you break this down. This one only had one choice. And that made the work much faster. Okay? So how can I make it harder? How can I make it harder is I make both of them composites. So let's make this 9x squared and this plus 10. Okay? Now you have two choices. I know that I'm going to have either 9 and 1 or 3 and 3. And here I'm going to have 1 and 10 or 2 and 5. So I'm going to have to break these two things. Now, the first numbers have to be what? Either 1 and 9 or 3 and 3. Right? That's the only choices I have. Where does it come from? 1 and 9 or 3 and 3. All right? What about the last numbers? The last numbers could be 1 and 10 or 2 and 5. And that's what you try. And then when you try them and you do the inside-outside, you're looking for whatever that middle term is. That's factoring method. Okay, if you don't see the factoring method, what can you always do? Use the quadratic formula. Okay? So, if you try it and it works, fine. If not, if you can't get it and you think you're wasting too much time, then use the quadratic formula because you know that'll work. The problem is, suppose that in the quadratic formula, you get this answer. X equals 3 over 2. Okay? What I want to know is, what value makes this a 0? So the first thing I have to do is move the 2. How do you move the 2? Multiply. And so that'll be 2x. How do I move the 3? Subtract. So that means that my original was 2x minus 3. All right, and sometimes doing the guess and check method is faster because when you have fractions, you still have more work to do. Does that make sense? And so had this been a negative here, then that would have been a positive there. Okay. This is the extra skill that happens when it asks you to factor and the first number is not a 1. This is the extra skill that has to be done. So sometimes it might be better to just try guess and check one more time. Make sense? Okay. All right. Questions? All right. Not trying to scare you. I'm trying to say that's a skill. That's an Algebra II skill that you should be able to do. Now, this is my personal opinion now. When you were in Algebra 1, you spent all that time using 1x squared.
Yeah.
And so when you use product sum, you looked at the last number and you split it into the end of the two binomials and you were done. Because the only way you can get 1 is 1 times 1. But when you got to the chapter that had, quote, harder equations, right, then it was not possible to use that skill because you couldn't just take the last number, you had to take the product of both numbers. Right? And so what I started doing after my first year is I skipped the part of the product sum and we went straight to the hard numbers. All right? And when you see how they split, then if it's 1, it's real simple because all you have to do is split the last one. Right? But the better skill is having to take the coefficient of the first times the coefficient of the second, and that's the product sum that you use. Does that make sense? Okay, so I hope that does, but I'm not trying to confuse you, but I'm trying to say that the Algebra II skill is much harder, and the old separating just the last term, just the constant term, does not work because the x is no longer 1. Okay, now, all right, let's see where we are here. Is this the one? Final exams. Okay, so that's solving quadratics. Here's some help if you want to do that. Chitty math, chitty math. All right, now, okay. Simplifying exponential expressions. Okay. Most of you did this real well. Okay, what happens when I have an x here and an x down? If I have a variable on top and a variable on the bottom, what do I do with the exponents? Subtract them, yes. If I have two side by side, like this and this, if the variables are the same, what do I do to the exponents? Add. All right, and then the one that's not shown here, if I have y to the second raised to the fourth, those are the ones that multiply. Okay, hello, nice to see you. Okay, we're doing Algebra II test review. Algebra II doesn't rhymes. All right, can't dance to it, but it does rhyme. Okay.
Is that a damn filled out?
All right, so questions?
That is awesome. I like your face, by the way. Thank you.
All right, okay. All right, so exponential expressions. This is one that's important. All right, and then the only one that seemed to give people trouble was if you have a negative exponent, how do you get rid of the negative sign in the exponent? You take the power to the other side of the fraction. So this negative 2, x to the negative 2 power that's in the numerator becomes x to the second power in the denominator. This becomes y to the fifth power. It's already positive, so it stays where it is. When you subtract here, you get z to the negative 3. Because it's the negative 3 power, I take it to the bottom, and it becomes z to the third power. Now, that would also mean if you had 1 over x to the negative 5, how do you get rid of the negative in that exponent? Is you take it to the top of the fraction. All right, now, everybody did really well on that, so I don't expect that those problems will scare you. Okay, now, Okay, Kramer's rule and systems of linear equations. Okay, systems of linear equations, if you have two things here, now this is a relatively simple example inside the box, because what happens when I add these two equations together? This will be x plus x, which is 2x, and this will be y minus y, which is 0. So when I take these two and add them, I get 8. If 2x is 8, 1x is 4. Then you take the 4 and you put it back in here, and 4 plus what number gives me negative 3? That's negative 1. You put both of them in here and it should equal 5. Right? 4 minus negative 1 is the same as 4 plus 1, and so that does equal 5. And so that's the intersection. Now, what Kramer's rule does is Kramer's rule uses, determinants. Right? And so what we're going to do in this case is that we're going to take the coefficients and we're going to have 1, 1, 1, and negative 1. Right? And those things are set up in what looks like absolute value marks, but they're not. Actually supposed to look like that, so it's a matrix. Now, we're gonna use two diagonals. So it's going to be this diagonal minus that diagonal. So 1 times negative 1 is negative 1, minus 1 is negative 2. So that means my denominators are negative 2. Now, the one that goes on top, and my recommendation is that you write it. That's the x. And then the y, we're going to take and keep this 1 and 1, and we're going to put the 3 and 5 here. Okay, now let's do this. This will be multiply 3 times negative 1, negative 3 minus 5. Negative 3 minus 5 is negative 8. So what is negative 8 over negative 2? It's 4. Negative 8 over negative 2 is 4. Alright, so that's Kramer's rule to get the same thing. Now, in all honesty, would you use Kramer's rule on that equation? The answer is no, because you can get it a different way. You can get it by linear combinations. But if you didn't see it, Kramer's rule always works. Okay? So now, this other one, to get the negative 1, when I take this, this times this, I get 5 minus 3, which is 2. And so this becomes 2 over negative 2, which is the negative 1. Okay? So, Kramer's rule for linear equations is quick and easy. Now, this right here is what I just explained. Right? I did this one when we did linear combinations. This is what I had in my notes, so I just put it up there, but we just explained it here. Right? So, and again, just like with a quadratic equation, using the quadratic formula always works. With two linear equations, using Kramer's rule always works. Okay? So if on a multiple choice test, if all the answers for the x value were different, you could use Kramer's rule just to find the x and then choose that one from the list. Right? If there were some that were the same, you might have to do both of them. Right? But Kramer's rule is something that you should have gained as a part of your ammunition for attacking linear systems from Algebra II. So we're going to test on that. Okay. Make sense?
Yes, sir.
Okay. All right, now, wow, we're really zooming along here. What time is it? 17? We go to 20?
Yeah.
Okay. Oh, that says 12. I can't, all right, well, I'm still getting used to it. Okay. All right, function notation. Function notation is fun. Everybody hates it, but it's really fun. Okay, so what does this notation mean?
Substitute.
Substitute the x for a 4 and tell me what you get. Okay? Then, what does this notation mean? It means substitute the x with all of g when g is 2.
So, yeah.
Alright? So substitute the x in f for all of g when g is 2. So the first thing you do is that you would go to g and substitute g for 2, get the answer, and then put that answer in for f. Okay? And then what would this mean? Substitute all of x for -1 in f.
And then G.
Alright? Okay. Now, if it were just this, f of g of x. Alright, now I'm not telling you to substitute a number for x. And so let's say that g of x is equal to 2x minus 7. Right? And f of x is equal to 3x squared plus 2. Okay? Now, what does this say to do? It says replace in f the x with g of x. So I'm going to come here and I'm going to say 2x minus 7 squared plus 2, and then simplify that. So now you're going to have to square, all right, and this is another place to get, what does 2x minus 7 to the second power, what does that mean? That means 2x minus 7 times 2x minus 7, which is 4x squared plus 49, and then 2 times 7, which is negative 28x. But if you were doing it, this would become 4x squared because it's this times this. The last numbers are plus 49, 7 times 7. And then what's the inside? Negative 14. And the outside is negative 14, which is 2 negative 14s, negative 28. Now, all of that in this problem would then be multiplied by 3, and we'd add 2 on the end. So we're not done, but that would be how you would simplify f of g of x given those values. Now, if you were doing a handwritten problem, would that be a good algebra problem? That would be a good algebra problem. Why? Because there's a lot of skills in there. Right? You have to understand what the notation is. You have to be able to interpret it correctly when you substitute. And after you're done substituting, you've got some actual algebra to do too. Right? So that would be a good, now yours is not going to be that hard. But if I were making the test, I'd give you one like that. Why? Why? Because I'm mean, I hate you, right? No, but seriously, if you can do that, what are you demonstrating? You're demonstrating you've got Algebra 2 skills. Right? Now, this problem is not a basic algebra problem. This problem shows the best students from the good students. Because the best students will come up with that answer. It's a lot of work and there's different skills involved. All right. So a single skill, and I'll give you this little hint. A single skill, like a definition, is called a depth of knowledge 1. That's basic. Right? When you have to create something, you get in depth of knowledge 3 or sometimes depth of knowledge 4. Right? And the depth of knowledge 3 and 4 are not separating the good from the bad students. They're separating the good from the best. Right? And so I would expect an average student would not get that right. Because there's so many places to make a mistake. Does that make sense? Right? Now, should you see 1 or 2 on a test? Yeah. Unless all you're doing on that quiz is covering the basics. Right? If not, if everybody gets 100, what do you say? If everyone gets 100, what's wrong with that test? it was basics, right? And everybody had the basics. And so I separated the good from the bad math students, but I still didn't separate the A's from the B's, the good from the best. Right now, if you make a test that's this tough, right, and you're teaching an honors class, you would expect that all but one or two would get this right. If you're in an honors class with all excellent students, right? And so, but if everybody's getting all of them right, then the type of testing should have moved up a notch. Okay. And in Georgia, the CRCT is not separating the A's and B's. All right. In fact, to pass the CRCT, now it's just changed, so I'm not sure about the most recent one, but all you had to have was a 50%.
Wow.
If you got 50% of the questions right, you hit the minimum, and therefore you pass. So I think it was like was it 400? I think that was it. I think it was like a 400 or whatever the number was. All right, all you had to get was 50% of the questions correct. Then you weren't really applying yourself, and you should have been way higher than that. My last year teaching middle school, we had, one of the problems that we had 148 special ed students. The special ed students that were not, that did not have a learning difficulty in mathematics, those special ed students had to score at the same rate as the rest of the school, which kept us in a needs improvement school for years and years, right? And so what we did is that we took those special ed students, and I actually brought the special ed math students into my class, and they learned alongside my students, right? And that last year we got them to pass because we looked at, because all we need to do is get them to get half the problems right. Right? And, you know, even if you make some silly mistakes, you should be able to get half of any test right. Okay? All right, now that takes us to the end. All right, we will finish this up. We've got a few left. I'm going to probably now start at the top and go to the bottom. All right, if you are wanting an excellent grade, you need this week to go through and look at these practice problems and make sure that you're not totally confused.
Yes.
All right, that's the first thing I'll ask is which skills do you want to go over first? That will be my question next week. Okay? All right, thank you for paying attention.
Thank you.